Up next, we're looking at infinities and vertical asymptotes and limits of infinities and all that good stuff. So, real quick, if you have a graph on an x and y plane and you have a function, and let's say at x equals 1, there's an asymptote here. So, your function is never going to cross this, right? But let's say on one side it's curving up like this, on one side it's curving down like this. Curving down like this, right? If your function looks like this, what is your limit when x is approaching 1 of f of x? Let's say this function is f. Well, your limit from the left, right, if you look at this, where's it approaching? It's going to go on forever and ever and ever and ever. It's never going to touch 1, but it's going to get infinitely close. So from the left, it's going to be infinity. And from the right, if we look at it, it's going to go down, down, down forever. So limit x approaching 1 from the right is going to be negative infinity because it's going down forever. This is just real quick, getting that out the way. If it's approaching an asymptote, it's going to be infinity or negative infinity, depending on which way it's going. Also, the limit when x is approaching 1 of f of x, like not from the left or from the right, does not exist here because this one's up, this one's down, and the two of them don't agree. Right? Infinity and negative infinity are not the same thing. So it's going two different ways. So at 1, there is no direct limit. It's either from the left or from the right. Okay, now let's try applying this to a function where you don't have a graph and you can't just look at it. And you gotta see for yourself, right? So if you look here, we have 1 minus x over x plus 4 when the limit when x is approaching negative 4, right? And you can't just plug this in because negative 4 plus 4 equals 0, and you can't do that, right? What would you do? Well, you have to find the left limit and the right limit. So if you look limit when x is approaching negative 4 from the right, since this is a vertical asymptote, should have said that. At negative 4, at x equals negative 4, there is a vertical asymptote because it can't equal that ever, right? So if you're looking at it from the right side, right, let's pick a number like slightly bigger than 4. So we'll go like negative 3.999, right? You have 1 minus negative 3.999 over negative 3.999 plus 4, right? So then subtract this out, you get 4.999 over 0.001, right? And then you have positive 4.999 divided by a number that's really, really close to 0. So you could just say that this is infinity because this number is so small and is divided into this. Since 4.999 is so much bigger than 0.001, you just say it's infinity. Plus, you know it's approaching it anyway because it's an asymptote. So the limit from the right side is infinity. So you can say that the limit from the right is infinity. Now, if we look at the limit from the left, limit when x is approaching negative 4 from the left side, let's pick a number that's slightly smaller than negative 4. So we'll go 1 minus negative 4.001 over negative 4.001 plus 4. And then we'll get 5.001 over negative 0.999, right? This is the same situation as last time, except the only difference is there's a negative now. So this is going to be negative infinity, right? So this graph is going to be going downwards forever, right? So the limit when x is approaching 4 does not exist, but from the right it equals infinity, and from the left it equals negative infinity on this function. We're going to look at one more. For one last example, let's look at this. The limit when x approaches 1 of x minus 3 over x squared minus 2x plus 1. So we can't plug in 1 here. It'll be 0. My cat woke up. Right, so we can't plug in 1. Blah, blah, I already said that. So the first step, as always, is we're going to factor. So we're going to have x minus 3 on top. You can't change that. And then at the bottom, we have x minus 1 and x minus 1, right? So we have an asymptote at x equals 1, which makes sense because we're looking for the limit of 1, right? So we're gonna try to find the left limit and the right limit, and we're going to see if they agree. So if we look from the left side, 1 from the left of f of x, we'll pick a number that's like slightly smaller than 1. We'll go like 0.999, right? So 0.999 minus 3 over 0.999 minus 1 squared, because that's just what this is. Yeah. So if we subtract that out, you'll get negative 2.001 over negative 0.001 squared. So if we have this is going to be a negative. We're going to square this, so this is going to be a positive. So we're going to have a negative number over a positive, really, really, really small number. So negative over a positive, this is going to be negative infinity. So this is going to be approaching negative infinity from the left. It's going to be like boom. Right? And if we look at it from the right side, f of x, when x is approaching 1 from the right side, we'll pick a number slightly bigger than 1. We'll go 1.001 minus 3 over 1.001 minus 1 squared. And that'll give us negative 1.999 over 0.001 squared, right? So once again, we have negative number over really, really small positive numbers with negative over positive. It's going to be negative infinity again. So on both sides of this graph, they're going to be approaching the asymptote like this. They're both going to be going down, right? So since the left limit is negative infinity and the right limit is also negative infinity, the limit when x approaching 1 of this function is negative infinity. So they're both agreeing, they're both going downwards. And even though they never pass the asymptote and they're both to infinity, they're like the same. They're the same infinity. So the limit is infinity. Moving on. Okay, last thing for this section, you have what if the limit of your function is approaching infinity. If x is approaching infinity of your function, right? But this is also the same as a horizontal asymptote. Because if you have a function on a graph and it looks like this, and it goes woo forever, right? When you have an asymptote, we're gonna make it blue. When you have a horizontal asymptote, that's like this, right? If in this function, when x is approaching infinity, and this asymptote, let's say it's at 2. When x is approaching infinity of your function, it's gonna go on and on and on and on forever on the x side, right? But it's never gonna pass 2. So the limit when x approaches infinity of this function would be 2, because that's the horizontal asymptote. So we're gonna go over like how to find that, and like, yeah, we're just gonna go over some practice problems, pretty simple. Okay, so one last thing before we get to problems, we're gonna go over 3 different types of like fractions and like what they mean. So if your limit, just in general, when x is approaching infinity, right? That looks like an 8. When x is approaching infinity, if you have a really, really big number on top and you have a small number on the bottom of a fraction, this is going to equal infinity, so there is no horizontal asymptote, right? Because the number on top is so big that the bottom one is just like irrelevant, right? So it's just going to keep going forever to infinity, your functions. If you have a big number on top and a big number on the bottom, they're going to cancel out and it's just going to equal 1 because it's like a number divided by itself, right? Because we're talking about like infinities here. So I'll give examples of these to make it like make more sense, but these are just like the generals you got to know. But if you have a small number on top and a super duper duper big, infinitely big number on the bottom, it's basically 0. So the answer is just 0 because like the number is so tiny that it's irrelevant. Okay, now we're gonna move on to some like practice. Make this make sense. Okay, so let's use these 2 problems right here as examples, right? So for the first one, we have x squared plus 7 over 14x minus 28. And x is approaching infinity. So how do we plug infinity into this, right? We just write infinity squared plus 7 over 14 infinity minus 28. Like what? It's just like weird, right? Like what do you do with infinities? You can't. It's not how that works, right? So you just see you have x squared here, right? Which is infinity times infinity if you plug it in. Like that is just so crazy big. Like you can't. It's the biggest. It's just big, right? And then you have 14 infinity, which is like, it's cool. It's kind of big, but that's not infinities, right? Because this is infinity squared. It's like when you're like a little kid and it's like, I'm better than you. I'm 2 times better than you. And then your homie's like, nah, I'm 3 times better than you. And then you're like, I'm infinity better than you. And then your homie's like, nah, I'm infinity better than you. Right? It's like so much bigger. It's infinity squared. It's so huge. So this is super duper big number on top and like relatively small number on bottom. So this is infinity. So the limit of this is just infinity because it's like it's gonna go up. It's so much bigger on top than it is on the bottom. That is infinity. Okay, and now let's look at this. We have x plus 8 and we have 4x plus 6. None of these is infinity squared. None of these is crazy big, but this one is 4 times bigger. So if you look and your x's exponent is the same, then you look at their coefficients, right? Because this is 1x and this is 4x, right? So the 4x's is bigger, but it's not crazy bigger. So you're just going to look at the coefficients and it's 1 over 4 is the answer to this. Because the horizontal asymptote is at 1/4, right? It's never going to pass that. So as x approaches infinity, your y is going to approach 1/4. It's never going to pass it. It's just going to level out as where it is. Yeah. So if the degrees, I think that's what's called. If the degrees are the same on your x's, then you look at the coefficients. And if the degrees are different, like in our first one, then if it's big over small, it's infinity. If it's small over big, it's 0. Also, if y'all are like, what about the 7? What about the 28 and the 8 and the 6? It's like they're so much smaller than this infinity squared and this infinity and this 4 infinity and this like those numbers are just so irrelevant that they don't even matter. Like on this one, I could even put like 7x minus 14, right? And you have 7 whole x's, you have 7 infinities right here. But this is just so like insanely big that nothing else matters. Like you should just look at the biggest degree of infinity that you have, the biggest degree of x that you have, and that's the one that you take into account. You don't worry about nothing else. Okay, now here's what you have to know. These are your 3 like most common type of functions that you're gonna have. You're gonna have ln x, x to the power of something, or e to the x. And you have to know that this is them in order of smallest to largest. This is just something you have to know. Like ln x functions, they increase very, very slowly, right? So they're very slow. So this counts as small. X to the x, or x to the power of something, or x to whatever is kind of just like mid. And then e to the x, or like a number to the power of x, grows a lot faster than x to the power of something. So this is like really fast, really big, right? If you have ln x, or limit when x is approaching infinity of ln x over x to the power of 4, for example, right? ln x is small. X to the power of 4 is like mid, but like compared to ln x, it's big, right? So this equals 0, because it's small over big. So it's just things like that. And then if you have like x over 4 minus ln x, and of the same problem, right? This is big over small, so this is infinity. So you just have to be able to recognize, like, if you have an x to the power of something over ln something, and you're looking for the asymptote is going to be infinity, it's going to go like forever, right? Because it's big on top of small, and then vice versa. And then e to the x, that's just the big vowels. Like, it's just the fastest, biggest. E could be replaced with a number, like if you have 6 to the power x over x squared, right? Even though x squared is big, right, is fast, 6 to the power x is so much exponentially bigger that if you're looking for the limit when x approaches infinity, this is big, this is small. Yeah, so you got infinity. Okay, one more. We'll go e to the power of x over ln x. The limit when x is approaching infinity. Take a guess. I'll give you a hint. This one's pretty big. This one's pretty small. But if you guess infinity, you're right. Congrats. But yes, this is what you need to know. You need to know that small, big, really big. Yeah, this is like, you don't use it that much, but it's just good stuff to know.